Okay, Ji, today we are going to do AS 9709 paper 1 2 for February March 2025. Okay, so without any wasting any minute, let's start. Question number 1 says that a curve has a equation y is equals to 5 plus 3x minus 2x square, and a straight line has a equation y equals to kx plus 13, where k is a constant. Find the set of values of k for which the curve do not meet the line. So basically when he talks about intersection or he uses the word meet, so the only thing that should come up to your mind is that the two lines are intersecting and the two y's has to be equal to each other. So let's put both the y's equal to each other, and it will be y equals y, and if I write 5 plus 3x minus 2x square equals kx plus 13, 2x square plus kx minus 3x plus 13 minus 5 equals to 0, and for further simplification it will be 2x square plus x bracket k minus 3 plus 8 equals to 0. So we have an equation, and since he says that they do not meet each other, so it means that the discriminant b square minus 4ac has to be less than 0. The value of a is 2, the value of b is k minus 3, and the value of c is 8. Let's substitute in the discriminant formula and put it equal to less than 0. So b will be k minus 3 whole square minus 4 times a times c, which is 8, less than 0. If I expand, it is k square minus 6k plus 9 minus 32. The value of a is 2. So it will be 64, not 32. So 64 less than 0. So k square minus 6k minus 55 less than 0. The two factors will be 11 and 5. So k square minus 11k plus 5k minus 55 less than 0. So k is common, k minus 11 plus 5 common, k minus 11 less than 5. The two brackets will be k minus 11 and k plus 5 less than 0. So let me just visualize it. So if this is the axis, and since it's a positive graph, so if I draw it like this, the two critical values that I will have, critical values, they are k to be 11 and k to be minus 5. But let me write down, these are basically the values for x critical values now. So this is one possible critical value, which is minus 5, and this is the other critical value 11. And if you could see here, it says that it is less than 0. So less than 0 means the region below the x-axis. So region below the x-axis means that the value for k has to be between minus 5 and 11. Okay, let's move to next question. Question number 2. Question number 2 says that the diagram shows the curve with equation y equals to 2x square minus 5 over x plus 3. The curve crosses the x-axis. So crosses the x-axis means that the value of y is 0, at the point P, which is 1 comma 3 1 comma 0, and M is the minimum point. So he says that find the gradient of the curve at P. So gradient of the curve means, let me write down the equation. Y is equals to 2x square minus 5x power minus 1 plus 3. So gradient means we need to find out the dy by dx at the specific value where x is 1, because we need to find the gradient at P. So dy by dx will be 4x plus 5x power minus 2 plus 0. So we know that the value we need to substitute for x at that specific place is 1. So dy by dx will be 4 bracket 1 plus 5 bracket 1 to the power of minus 2. So 4 plus 5 bracket, so that's 1. So basically the gradient will be 9. Find the coordinates of M. Give each coordinate correct to three significant figure. So we can see that, and it's also mentioned in the question that M is basically the minimum point. So we know that minimum point, or the turning point or the stationary point, they all have the gradient as 0. So dy by dx will be equal to 0. So, and we already have found the dy by dx, which is 4x plus 5 over x square, and it has to be equal to 0 because that's the minimum point. Now if I simplify, it will be 4x equals minus 5 divided by x square. So x cube will be equal to minus 5 divided by 4. So I have to take cube root on both sides. Cube root for 5 by 4. The answer will be, the value of x that I will have correct to three significant figure will be minus 1.08 is the value for x. So to find the value of y, I'll just substitute in the above equation, which is 2x square. So let's just directly substitute, which is 2 bracket minus 1.08 square minus 5 over minus 1.08 plus 3. So 2 bracket minus 1.08 square plus 5 over 1.08 plus 3, and the value is for y correct to three significant figure is 9.96. So the coordinates of M correct to three significant figure are minus 1.08 and 9.96. Question number 3. Find the complete expansion of this. So complete expansion is very simple. We just need to put it in the formula of NCR, a power n minus r, b power to the r. So 4c0 bracket 2x power 4 bracket minus 3 over x whole power 0 plus 4c1 bracket 2x power 3 and minus 3 over x whole power 1 plus 4c2 bracket 2x to the power of 2 bracket minus 3 over x to the power of 2. Similarly, plus 4c3 bracket 2x to the power of 1 and minus 3 over x to the power of 3 plus 4c4 bracket 2x to the power of 0 and minus 3 over x to the power of 4. Now let's do the expansion. 4c0 and 4 power 4 is 16. So 16 x power 4, and anything to the power of 0 will automatically become 1. So this is the first expansion that I will have, plus 4c1 4, that's 4, which is times 8, which is 32, but there will be a negative sign, negative 32, 4c sorry, times it with 3 as well, which is 96, negative 96. X cube divided by x will be x square, plus 4c2, which is 6 to the power into 4 into 9, which is 216. X square and divided by x square will become 0, but x to the power of 0, plus 4c3, which is 4 times 2 times minus 27, which is again minus 216, and x is in the numerator and x cube is in the denominator, so we will be left with x square only, plus 4c4, which is 1 times 1 times 3 to minus 3 to the power of 4, which is 81, divided by x power 4. So this is all the expansion that we have. Hence determine, hence means that you need to use the working or the answer from the previous part. Determine the coefficient of x square when you multiply the first bracket with the already expanded thing above. So x square plus 5, I need to multiply this thing with which terms in the second bracket so that I can have x square. So remember, this x square term will multiply with a simple constant number which does not have any x variable with it, so that it can give us x square term. So there is only one term such that, which is 216, and for the next one, which is a simple term without any x with it, I have to multiply with the x square term so that I can have a x square term. So if I say it is minus 96x square, the second one. Now I'll do this expansion. So it's 216x square minus 96 into 5, which is 480x square. So 216 minus 480, the answer is minus 264x square. Okay, let's move to the next question, question number 4. Question number 4 says, the diagram shows a triangle OAB, okay, where OA is equals to OB is equals to 10. So the complete side is 10. Angle AOB is 0.8 radians. So let's change the calculator mode to radians. Point C and D on OA and OB respectively are such that arc ACD is part of a circle with center O. So basically he is saying that this 6 centimeter is the radius of the circle. The shaded region is bounded by the arc CD and the line segment AB and BD. Okay, we need to find out the perimeter of the shaded region. So for finding out the perimeter, we basically need to add these 4 sides. Out of these 4 sides, we are already aware of the 2 sides, which is 4 and 4. We need to find out the other 2 sides and add them all to find out the perimeter of the shaded region. So let's first of all find out AB. AB is a triangle in which 2 sides are given to you, and the angle between the 2 sides is also given. So we will apply cosine rule here. So cosine rule will be 10 square plus 10 square minus 2 times 10 times 10 cos 0.8. So it will be 100 plus 100, 100 plus 100 minus 200 times cos 0.8. So if I simplify, the AB square value will be 60.6586. So if I take square root, I will have the value for AB, which is 7.79 centimeter. Now I have AB length already with me, which is 7.79 centimeter. Now we need to find out the arc length CD. So CD is an arc length, and for that we will use the formula S is equals to R theta. R theta. R is the radius and theta is the angle between the radiuses. So it will be 6 times 0.8. So 6 times 0.8 is 4.8 centimeter. So this is 4.8 centimeter. So to find out the perimeter, we will add all the outer sides of the shaded region, which is 4 and 4, and we also have 7.79 plus 4.8. So 4 plus 4 plus 7.79 plus 4.8, which is the perimeter is 20.59 centimeter. So this is the perimeter of the shaded region. In the next part, he says that find the area of the shaded region. So to find the area of the shaded region, we first of all need to find out the area of the complete triangle, from which we can subtract the area of the sector which is unshaded. So let's find out the area of the triangle first. So area of triangle, which is 1 by 2 into the two legs of the triangle are 10 and 10 centimeters each, and the angle in between the two sides is 0.8 radians. So 0.5 times 10 times 10 times sine 0.8, which is 35.8678 centimeter square. Now we need to find out the area of sector, and for finding the area of sector we have the formula 1 by 2 r square theta. The value of the radius is again 10 and theta is 0.8. So 0.5 times 100 times 0.8, the answer is 40. So sorry, the radius is not 8, it's 6. The radius is 6. This is the radius, na? This is the radius of the sector. So this is 6. The complete length of the triangle is 10. So it's 6. So 36 times 0.5 times 0.8, which is 14.4 centimeter square. So area of shaded region. So area of shaded region will be total area, which is 35.8678 minus 14.4. 8678 minus 14.4, which is 21.4678. So basically 21.5 centimeter square. Okay, the question number 5. The question 5 says an arithmetic progression has the first term 5. So this is basically the question is arithmetic progression, and the first term is 5. So the value of A is 5. The common difference D is 6. So he says that for this progression, find the sum of all the terms that lie between 150 and 400. So we need to find out the sum that lies between the term which is giving the value as 150 and the value 400 or less than 400. closer to 400. So let's first of all, let's see which are those values of n. So the formula is a plus n minus 1 into d. It has to be less than 150, and similarly it has to be less than 400. The value of a is 5, the value of n we need to figure out, and the value of d is 6, less than 150. So n minus 1 will be less than 150 minus 5 divided by 6. So 150 minus 5 divided by 6, which is 20. N minus 1 less than 24.16. So the value of n has to be 25.16. So it has to be less than this. Okay. Similarly, let's substitute the same. 5 plus n minus 1 into 6. It has to be less than 400. So n minus 1 will be less than 400 minus 5 divided by 6. 400 minus 5 divided by 6, which is 65.833, less than n minus 1. So the value of n has to be less than 66.833. Okay, so we need to find out the sum, which has to be and obviously the value of n has to be the integer. So we need to find out the sum between the 25th term and 66th term. So we will find out the sum for the first 66 terms. The formula is n divided by 2. So the value of n is 66 divided by 2 bracket 2 times a, which is 5, plus n minus 1 into d. So n minus 1, which is 66, minus 1, which is 65. The value of d is 6. So 33 bracket 10 plus 65 times 6. The answer is, the sum of the first 66 terms is 13200. Similarly, we will find out the sum of the 25 terms. So for that, 25 divided by 2 bracket 2 bracket 5 plus 25 minus 1, which is 24, times 6. So the sum will be 12.5 bracket 10 plus 24 times 6. The answer is 1925. So basically we need to find the difference of the two sums, which will be 13200 minus 1925. So 13200 minus this, which is the sum that lies between these values, is 11275. So let's move to the next question, question number 6. Question number 6 says that the diagram shows a circle C of radius r, where x is greater than 0 and y is also greater than 0 for all the points on C. So wherever the point C lies on the circle, the value of x has to be positive, and so does the value of y. The least distance between any point on C and the x-axis is 8 units. So basically the least point that lies on the circle, which is closest to the x-axis, has to be right here, the right below the radius. This will be the radius, and he has told that the distance of the lowest point from the x-axis has to be 8. Similarly, he says that the least distance between any point on C and the y-axis is 5. So if, for example, this is the least, obviously this can be the only least point. So the distance from the least point till this point from the center will be the radius, and the distance from this point on the circumference and the y-axis has to be 5. So what we need to do is we need to state the coordinates of the center of the circle in terms of r. So the coordinate for the center, the coordinate of this point, how much are we moving in the x direction? We are basically moving r plus 5. And how much are we moving in the y direction? We are moving r plus 8. So the coordinates are going to be r plus 5 comma r plus 8. Okay, the next part says given that the distance between the origin and the center of the circle is 15. So basically what is he trying to say is that if you draw a straight line from the center, which is 0 0, the coordinates of center is 0 0, and similarly we are already aware of the coordinates of the center in terms of r, which is r plus 5 and r plus 8. He has told that the distance between these 2 points is 15. So all what you need to do is you need to apply the formula for distance. Let me write down the coordinates r plus 5 and r plus 8, and the other coordinates are obviously 0 0, and the distance between the 2 points is 15. So the formula is 10 equals square root of x2 minus x1, since x2 is 0, so r plus 5 whole square, plus the y is also 0, so just r plus 8 whole square. We'll take square on both sides, so 100 will be equals to, I have to expand it as well, r square plus 10r plus 25 plus r square plus 16r plus 64. So it will become 2r square plus 26r plus 25 plus 64 minus 100. It will be it has to be it will be 25. It will be, oh, the radius is 15 here, so it will be 225. So it is 25 plus 64 minus 225, which will give us minus 136 equals to 0. I have to put this value in the equation. I have to do the midterm breaking. 226 and minus 136. The value, one value of r will be 4, and the other value of r will be minus 17. The value he has stated very clearly in the it's the value of r that we have just found out, and since it's the radius, so what we will do, we will ignore it, and the only radius that is acceptable will be the value of r to be 4. Okay, the next question says the point on the circle furthest from the origin is denoted by P. So for it to be the furthest from the origin, it will definitely be the extension of this line. So this will be the point P, the one that I just marked. He says that find the gradient of the tangent at the circle to the circle at point P. So what we can do is, we know the coordinates, we know the value of r, we can easily figure out the coordinates of the center. The coordinates of the center are r plus 5 and r plus 8. So if I just substitute the value of r to be 4, so it will be 4 plus 5 9 and 12. So the coordinates for the center is going to be 12. So the gradient will definitely be the same throughout the line. So the gradient of this line, the one from this point to the point from O to P, so the gradient of O to P will be 12 minus 0 divided by 9 minus 0. So 12 divided by 9, which is 4 by 3. So this is the gradient of the line OP, but he is asking you to find out the gradient of the tangent to the circle at P. So the tangent is definitely going to somehow look like this. So if this is the tangent, I hope you remember the property that the tangent and the radius, they make an angle of 90 degree. So the angle 90 degree lies exactly over here. So, and we know that the gradients are negative reciprocal of each other. So gradient of tangent will be minus 3 divided by 4. Question number 7. Show that 3 tan square plus 5 sin square theta is equal to this. So let's take the left hand side, and instead of tan theta we will convert it into sin theta over cos theta. So it will become 3 bracket sin square theta divided by cos square theta plus 5 sin square theta. We are supposed to prove the left hand side that we have chosen equal to the right hand side. So if I simplify, and I can see that on the right hand side I don't have any cos. So what I will do is I will convert the cos square theta into sin square theta. So it will become 3 sin square theta divided by 1 minus sin square theta plus 5 sin square theta. So I have to take the LCM so that I can make the denominator same. So if I take the LCM, it will be 3 sin square theta plus 5 sin square theta bracket 1 minus sin square theta, and the denominator will be 1 minus sin square theta. Let's do the expansion and simplification. So it will be 5 sin square theta minus 5 sin 4 power 4 theta divided by 1 minus sin square theta. So the like terms, if we add them, it will be 8 sin square theta minus 5 sin 4 theta divided by 1 minus sin square theta, and that is, I think, what we were supposed to show. For 8 sin square theta minus 5 sin 4 theta over there. Okay, the B part says hence solve the equation. So I hope you remember that whenever we will do hence, it means that we need to take the working from the previous part to solve it. So the working that we have just identified is this working. Let me copy. So we will put the left hand side of this equation and we will put it equal to 9, because in the previous part we have proven that this side is that side is basic, this thing that is given to you, it is equal to the one that I have just written over here. So let's just simplify. It will be cross multiplication 8 sin theta minus 5 sin 4 theta equal 9 minus 9 square theta. Now let's simplify. We'll take the bigger power to the right side, so it will be 5 sin 4 theta minus 9 sin square theta minus 8 sin square theta plus 9 equal to 0. So simplify the like terms. It will be 5 sin 4 theta 9 plus 8 minus 17 sin square theta plus 9 is equals to 0. So let's make it easy. Let's put sin square theta and we can put it equal to x. So the equation will become 5x square minus 17x plus 9 equal to 0. All we need to do is to do the midterm breaking. So 5 minus 17 and plus 9. Okay, so the two values of x that I have found is 2.744. The other value of x is 0.65596. Now okay, now I know that sin square theta is equal to this value of x, which is 2.744, and sin square theta is also equal to 0.65596. I'll take square root on both sides. So sine theta will be equal to 2.744. So it is basically 1.6565, and obviously it has to be positive and negative both, and similarly 0.65596, which will be sine theta equal plus minus 0.80991. We know that the sine value cannot be greater than 1, so we will write not possible. It has to be between -1 and +1. So we have to solve that portion. I will write both the portions separately, one time positive and the other time negative. Sine theta equals minus 0.80991. Let's solve the left hand side first. So I have to find out the alphas, the angles with the origin. Since the sign is positive here, sign is positive in the first two quadrants, so I will make both the angles. I have to find alphas over here. So sine, it's in radians. Remember, you have to convert your calculator back into degrees. So sine inverse 0.80991, which gives you the alpha as 54.087. 54.087. So the two values of theta are very clear from you. Let's see what are the limits. The limits are from 0 to 270. So both of them are possible, which is 54.08 degrees, and the other is 180 minus 54.087, so which is 125.9 degrees. Similarly, if I make another diagram for the right side, the sign is negative in the last two quadrants, so this and this. The value of alpha, we always find it without the negative sign, without any sign basically. So if I find the value of alpha, it will be 54.087, both sides. But there is a difference, that our limits, our domain of the question is starting from 0, going in the anti-clockwise direction up till 270. So this is the only angle that is left up till 270, because the other angle is going up till 360. So theta will be 270 plus 54.0, sorry, it's 180 plus 54.08, so which is 234.08 degrees. So these are the three values of theta that are possible. The other value of theta is not possible because that is exceeding the domain limits given to us for solving this equation. Okay, let's do question number 8. Question number 8 says that a geometric progression is such that so remember, it is a geometric progression. Its second term is minus 120. So AR is basically minus 120. And he also says that the sum of infinity is 160. So sum of infinity formula is A divided by 1 minus R. Remember that the sum of infinity formula is only applicable when the value of R is between -1 and +1. So he says that we need to find out the common ratio. Common ratio means we need to find R. So 160 into 1 minus R is equal to A, and similarly A is equals to 120 divided by R. And since both of them will have the same A value, let's put the A values equal to each other, which will be 160 minus 160 R is equal to 120 divided by R. So it will be 160 R minus 160 R square equals to 120. So it's minus 120, so minus 120. If I simplify, it will be 160 R square minus 160r minus 120 equal to 0. Now let's solve it. So 160 minus 160 minus 120, the values of r is 3 by 2, the other value of r is minus 1 by 2. This is not possible because the value of r has to be between positive 1 and negative 1. So this is the only value of r that is possible for this question. The first 9 terms of the progression are now removed. Find the sum to infinity of the remaining terms of the progression. So basically he is trying to say, is term 1, term 2 up till term number 9, they are all removed from the terms. They are no longer present. We need to find out the sum of the remaining terms. So in this scenario, this T10 is basically going to become the new A. Okay, so we need to find out basically this T10 first, and for finding the T10 we need to find out this A as well. So what is A? How can we find A? Minus 120 will be equal to r, we already have it, minus 1 by 2, so it will be A bracket minus 1 by 2. So the value of A will be minus 120 divided by negative 0.5. So the answer for A is 240. This value of A is for the previous term when the sequence is series is starting from the term 1, but now the series is starting from term number 10. So let's find out the term number 10, which will be the first term now. So 240 plus 9 into the oh sorry, it's the not arithmetic, it's the geometric. So it will be T10, which will be equal to 240 bracket minus 1 by 2 to the power of 9. So 240 into 0.5 to the power of 9, which is, so T10, which will be 15 by 32. Remember, this T10 will be the new A now, and we simply need to find out the sum of infinity. So sum of infinity will be so sum of this is negative. So this is negative. Okay, so sum of infinity is A divided by 1 minus r. So minus 15 over 32 divided by 1 minus 0.5. So minus 15 divided by 32, 1 minus 0.5. So the value of sum of infinity is minus 5 over 16. Okay, so let's move to the next question, question number 9. Question number 9, then comes 10 and followed by 11. Okay, let's come back to question number 9. Question number 9 is that a curve is such that d square y over dx square is this. It is given that the curve has a stationary point which is 1 by 2 comma 9. Use the expression for the double derivative to determine whether the stationary point is maximum or minimum. So for finding out the the nature of the stationary point, we definitely use the double derivative, which is d square y over dx square, and we just need to substitute the x value for the stationary point. So we can substitute is 0.5 to the power of minus 4, 5 bracket 0.5 to the power of minus 3. So 6 bracket 0.5 to the power of minus 4 minus 5 times 0.5 to the power of minus 3, and the value is 56. Since the double derivative value is positive, d square y over dx square is positive, so its minimum point. So what are the coordinates of the minimum point? 1/2, 9. The next part says that we need to find out the equation of the curve. I hope you remember that from the double derivative going back to the equation, we need to do integration. So if I do the integration one step before, it will be dy by dx, and we need to do the integration 6x power 4 minus 5x power minus 3 dx. So we just need to do the integration 6x power minus 4 plus 1, which is minus 3, divided by minus 3, minus 5x power minus 2 divided by minus 2. And remember, we have to put c constant because we are not putting any limits. So if I simplify, it will be minus 2x power minus 3, 5x power minus 2 plus c. So this is the equation for the derivative, the first derivative. And if you go back to the question, he says that the stationary point is this. So I hope you all can recall that stationary point means the dy by dx is equal to 0. So we can substitute the value of dy by dx as 0, and we know that where specifically it is at the value of x being 0.5. So dy by dx is 0, where the value of x is 1/2. So 0 is equal to minus 2 bracket 1/2 to the power of minus 3 plus 5 bracket 1/2 to the power of minus 2 plus c. So minus 2 bracket 0.5 to the power of minus 3 plus 5 into 0.5 to the power of minus 2. So, and this will be the value of, if we simplify, it's going to give us the value as, okay, the value, if we simplify, we will have the value of c as 6. So okay, now after that we have the new equation with us for the dy by dx. For the dy by dx, the equation is dy by dx equals minus 2x power minus 3 plus 5 over 2x power minus 2 plus 6. Now still we don't have the equation as yet. We have to find another integration. So if I do the integration for dy by dx, it will be y, and for further integration it will be minus 2x power minus 2 divided by minus 2 plus 5/2. So if I minus 2 plus 1, it's minus 1. So 5/2 into minus 1 x power minus 1 plus 6x, and remember we have to put a constant. Let's put it as p. So if I simplify, it will be x power minus 2 minus 5 divided by 2 x power minus 1 plus 6x plus p, which is y. Now we know that the coordinates as well. We know the coordinates of the stationary point and we can use them, which is 1/2, 9 to find the value of p. So if we substitute as 9 over here, and we substitute 0.5, which is 1/2 minus 5/2 into 0.5 to the power minus 1 plus 6 into 0.5 plus p. So it will be 0.5 to the power of minus 2 plus 2.5 into 0.5 to the power of minus 1 plus 6 into 0.5. The answer will be, if we simplify it further, it will be the value for p after simplification. It will be 7. So the final equation will be y is equals to let me just, so the value for y, the equation will be x power minus 2 minus 2.5 x power minus 1 plus 6x plus 7. So this is the equation of the curve. Let's move to the next question. Question number 10. The question 10 says the diagram shows the curve with this equation, this for values of x such that 0 to 7, for 0 to 7 the tangent to the curve at point P. Okay, so basically this is the point P, meets the y-axis. So this line meets the y-axis at Q. Region A is bounded by the two axes, we can see that, and the region, there is a segment above which is region B. So we need to find out the area of the region A. So we know that this is 7 and that is 0. So we can find that as well, because y is 0. So let's substitute the y0 in the above equation. It will be 4 bracket 3x plus 4 to the power plus 1 by 2 minus 2x minus 6. So it will be 2x plus 6 equals 4 bracket 3x plus 4 to the power of 1 by 2. So we divide it. If we divide, we will have 0.5x plus 6 divided by 4, which is 1.5, equals 3x plus 4 to the power 1 by 2. We will take square on both sides. So if we take square on both sides, we will have 0.25x square plus 2 into 0.5 into 1.5, which is again 1.5x, plus 1.5 square is 2.25, and it will be equal to 3x plus 4. Simplify 0.25x square plus, not plus, it will be minus 1.5x minus 2.25 minus 4, which is minus 1.75 is equal to 0. So if we substitute 0.25 minus 1.5 and minus 1.75, okay, so one value of x is 7 and the other value of x is minus 1. This is beyond the scope. It is not available to us in the graph. So the value of x at this specific point is 7. So we need to find out the area under the region under the curve, which is this. So area under the curve, area can be calculated by doing integration area under A. So the limits are from 0 to 7 and the curve is 4 bracket 3x plus 4 to the power 1 by 2 minus 2x minus 6 dx. So if we need to do the integration, we have to have the differentiation of the bracket outside. So it will be 4 divided by 3. Let me do it completely so that it's easy for you to understand. 4 is outside, so it's 3x plus 4 to the power 1 by 2. We cannot do the integration until we have the differentiation of the bracket. We will introduce this 3 ourselves and we'll divide by 3 as well. So now we can do the integration. The integration will be 4 by 3 bracket 3x plus 4 to the power 1.5, which is 3 by 2, plus minus 2x square divided by 2 minus 6x, and the limits that we need to substitute is from 0 to 7. So let's substitute from 0 to 7. If we substitute from 0 to 7, remember we also have to divide by 1.5, so we have to do the division by 1.5. Okay, so this will become so if we simplify, so if we simplify, it will be 4. 3 times 3 is 9, and this 2 will come up because, let me show it clearly, 1.5 is basically 3 by 2, so 3 will remain in the denominator, 2 will go in the numerator, bracket 3x plus 4 power 3 by 2 minus x square minus 6x, and the limits are from 0 to 7. Now if we substitute the limits, let's substitute the limits. 8 over 9 bracket 21 plus 4 to the power 3 by 2 minus 49 minus 42. This is the upper limit, minus the lower limit is 8 by 9 bracket 4 minus 0, so that's it. So it will be 8 by 9 bracket 25 to the power 3 by 2 minus 49 minus 42, which is 181 by 9 minus 8 by 9 into 4, which is 32 by 9. So if I simplify, 181 by 9 minus 32 by 9, it will be 140. So if you simplify, no, it will be 8 by 9 into it's basically minus, and it will be 0, and it has a power of 1.5 as well. So this is basically not 32, it's 64 by 9. So 181 by 9 minus 64 by 9, it is 13. So 13 units square. This is the area of the region A. Now we need to find out the area of the region B. So for finding out the area for region B, we have to find the area of the complete triangle, and by finding the area of the complete triangle, we have to subtract the area of the region A that we just found out to be 13. So for finding out the area of the triangle, we need to find out the coordinates for Q. The coordinate x coordinate for Q is already known, and we just need to find out the y coordinate for Q. So how can we do that? We know that this is the tangent line, which is tangent at P. So we need to find out the derivative for finding out the equation of that line. So dy by dx will be equal to it will be 4 bracket 3x plus 4, and its power is 1 by 2. So if I subtract 1 from it, it will become minus 1 by 2 into the derivative of the bracket, which is 3. So derivative of the bracket, which is 3, and then what is next? Minus 2 as it is. So if I simplify it further, it will be and I know that the gradient, I need to find it for the specific coordinates, which is 7, 0. I need to substitute the value of x to be 7 in here. So if I substitute the value of x to be 7, and I have to multiply with the power as well, the old power which was 1 by 2. Then before subtracting I have to do that, so it will be 4 divided by 2 bracket 3 times 7 plus 4 to the power minus 1 by 2 into 3 minus 2. So if I simplify, it will be 4, 2 times 6, so 2 times 3 is 6, 6 bracket 21 plus 4 to the power minus this, and if I simplify, I have the gradient as the gradient or value of the gradient is minus 4 by 5, and I know that the coordinates at that specific point is 7, 0. So so let's find out the equation of that tangent line, which is y minus y1. y1 is 0 into m, which is minus 4 by 5 into x minus 7. So y will be minus 4 over 5x plus 28 over 5. So this is the equation of the tangent line. Equation of tangent line at P. So we know, so for finding the coordinates of Q, what we need to do is, we know that Q is a place where the value of x is 0. So we'll substitute the value of x as 0. So the value of y will be 28 by 5. So the coordinates for Q will be 0, 28 by 5. Now we can easily figure out the area of triangle, which is 1 by 2. Base is, this is the base of the triangle, which is 7, and this is the height. Since we found out 28 by 5, the height is this, which is 28 by 5. So area of the triangle will be 1 by 2 into 7 into 28 by 5. So 0.5 into 7 into 28 by 5, which is 19.6 unit square. Area of the region A is already known, which is 13. So area of B can be calculated, which will be 19.6 minus 13, which will be 6.6 unit square. Let's move to question number 11, and question number 11 is the last question. Okay, question number 11 says that function f and g are defined such that for all real values of x by f function and g function where c and k are positive constants, so they are both positive constants, it is given that g inverse with some input value is c. So let's first find g inverse. So y is equals to 2x plus k. So y minus k is equals to 2x. So x will be y minus k divided by 2. So we will substitute g inverse of y, which will be y minus k divided by 2. The last step for inverse is g inverse of x, which will be x minus k divided by 2. And he has told to us in the question that if we input the value in the inverse function as 3k plus 1, it will give us c. So let's put 3k plus 1 in place of x. So 3k plus 1 minus k divided by 2, and since it is equal to c, so it will be c will be equal to 2k plus 1 divided by 2. Let's read the question further. What is he saying? Show that g f of x is this. So we need to substitute the f function into the g function. So f function into the g function. So g f of x will be 2 bracket 4x square minus c plus k. If we expand it, it will be 8x square minus 2c plus k. I hope you can see that there is no c over here. We will replace this c with the existing value of c that we just found out in the previous part. So it will become 8x square minus 2 bracket 2k plus 1 divided by 2 plus k. 2 and 2 will cancel out. It will be 8x square minus 2k minus 1 plus k. So this will simplify. It will be 8x square minus k minus 1. And yes, this is what we were supposed to show. Gf of x. Okay, now the next part B, the curve with the equation y is equals to this, we already found, is transformed to a graph with equation y is equals to h of x by the following sequence. So basically this curve is being transformed to another function which is h of x, which is having a translation of this and that. First translation, then stretch with in the y direction, and then the reflection in the x axis. We need to find an expression in terms of x and k. So let's do it step by step. So the function that we have in the start, we have the function over here which is 8 x square minus k minus 1. We need to do the translation first. So translation is basically that we need to f x minus 2 plus 3. This is the translation that we need to do. So let's do this translation, which will make the function as 8 bracket x minus 2 whole square minus k minus 1 plus 3. If I simplify, it will be 8 bracket x minus 2 whole square minus k plus 2. The first step is done. Now we have to do the stretch in the y direction. So stretch in the y direction, this is the first step. The second step is stretch in the y direction. So to do the stretch in the y direction, and the scale factor has to be k. So what it will be k bracket f of x minus 2 plus 3. This is what we need to do. We just need to multiply the previous function that we found out with k. So it will be k bracket 8 bracket x minus 2 whole square minus k plus 2 bracket close. If we simplify, it will be 8k bracket x minus 2 whole square minus k square plus 2k. The last step is that we need to do the reflection in the x-axis. So reflection in the x-axis means that we are going to change the y, which will simply multiply with the negative sign. So negative k bracket f x minus 2 plus 3. So just simply multiply the above function with minus sign. So minus 8 k bracket x minus 2 whole square. If I multiply the next with the negative sign, it will be positive k square minus 2k. Remember, this is the function h of x now, because this is being transformed. Okay, the next part is the range of h is given by h of x is less than 15. So let me write down the h function first. H of x is basically minus 8k bracket x minus 2 whole square plus k square minus 2k. And if I write down, this is, or the equation is written in the form of turning points. Turning point equation is written over here. So what it is a bracket x minus b whole square plus c, where the turning points in the scenario is b comma c. So we can easily see that the turning point over here, let me sketch the graph first. The graph is going to be upside down. This is going to be the stationary point, the one right on the top that I marked with red, and the coordinate of the stationary point are going to be the one coordinate is x is going to be 2, and the y coordinate will be k square minus 2k. And he said that it has to be less than or equal to 15. So we can say that k square minus 2k can be equal to 15. So k square minus 2k minus 15 is equal to 0. I can figure out the value for k, which is 1 minus 2 minus 15. Okay, the one value for k will be 5, and the other value for k will be minus 3. I'm sure he must have mentioned something in the question. Yes, he said that k and c both are positive, so the negative value is not possible. We will reject that negative value. So we have the k and we are supposed to find c. This is the equation for c, which is 2k plus 1 over 2. So c is 2k plus 1 divided by 2. Just substitute the value of k as 5. So 11 divided by 2. Okay. Yeah, sorry, the c is basically, yeah, the c is 1 by 2 bracket 2k plus 1. So 1 by 2 bracket, we just need to substitute the value of k as this one, and we can find the value of c. 2 times 5 plus 1, and which will give us the value of, we can have the value, so 1 divided, it will be 5 times 2 plus 1 divided by 2, and the value of c will be 5 plus 1. The value of c will be 5.5, which is c. Okay, I hope you have understood all the questions. If you have any query, please leave it in the comment section so that I can answer. In a couple of days you have your exam. Wish you all the very best. Share it with your friends if you like the video, and if there is any suggestion, still mention them in the comment section. I hope it has helped you all to progress. Wish you all the very best. Take care. Allah Hafiz.